Hello everyone. In this video we're going to look at how we can calculate what's called gravitational potential energy and kinetic energy. Now these two are very closely related. When you first do any physics in school, you normally talk about types of energy in terms like heat, light, sound, elastic. Then you mention these: gravitational potential, kinetic. But these two have a really important kind of connection because they very much relate to one another. Now the scenario that I kind of use is, imagine that we've got just the ground here, we've got person here, little smiley face, and I want you to imagine that the body's gone a little bit wonky there. I want you to imagine that they are lifting up above their head some dumbbells on a bar. So they're lifting up some weights here. Now, when that dumbbell is lifted off the ground, it stores energy. And the energy that it stores is referred to as the gravitational potential energy. So the GPE, is it shortened to, the gravitational potential energy, so the GPE there, is energy stored in an object when lifted to a high position off the ground. So we'll just make a note of that. So it's energy stored in an object when lifted off the ground. Now another classic example is to think of like roller coasters, and that when you look at the car at the top, the peak of a roller coaster, you say that it's full of gravitational potential energy. Now we'll come on to kinetic, but we'll just deal with this one first. Now the value for the gravitational potential energy depends clearly on the mass of the object that we're looking at and the height above the ground that we're lifting that object to. But it also depends upon the strength of the gravitational field, because gravity is going to be acting on that mass, pulling it down. So GPE, if we were to put the formula in place for this one, GPE, or more specifically the change that we get in gravitational potential energy, would equal the mass of the object times by our gravitational field strength. And as we said, that also relies on the change in height, so we'll put that there. Change in height. There we go. So there's our formula to calculate the change in gravitational potential energy. Now let's put some units to this. So because we've got a change in gravitational potential energy to begin with, the units for that would clearly be joules. The units of mass we take as kilograms. Gravitational field strength would be newtons per kilogram. And the change in height we take as meters. Now there are symbols that we can use to represent each one of these things here. So change in the GPE, often we can just refer to as E, and we put a little p at the bottom. So E is for energy ultimately, and P is potential. So the potential energy, gravitational potential energy. So EP is equal to M times G times H. G being gravitational field strength and H being change in height. Now just to say that this value here, G, we often, sometimes they simplify it and use a value for 10, but on Earth that G value is 9.81. So you can use that, or you can use the value of 10 to represent that. And that there gives us our formula to calculate gravitational potential energy, or the change in the potential energy. Now if I were to drop this dumbbell, so I've been holding it above my head, if I were to drop it and let it just fall down to the floor, then we say that that has kinetic energy. Kinetic energy is the energy that a moving object has. So we're going to put this one up at the top here. So KE, kinetic energy, is energy a moving object has. And let's just put down a formula for that. So to be able to work out the kinetic energy, we need to again look at certain factors that are going to affect it. And in this case, it's going to be the mass of the object and the speed that it travels at. So our kinetic energy is equal to, now it turns out in this formula, 0.5, so it's a half, times by the mass, times by our speed squared. So if we were to look at units again for this, because it's kinetic energy, our units for that are going to be joules. Our units for mass, again, in kilograms, and our speed would be in meters per second squared. And once again, we could put another symbol kind of equation to this. This time kinetic energy we're going to refer to as E, but with a K for kinetic. And that's equal to 0.5 times m times v squared. Where this time now, we're getting a value for our kinetic energy. So EP equals m times g times h, that's for potential energy, whereas EK is 0.5 times m times v squared. And all you'd have to do is just substitute different values into these two equations to calculate both. So we've got here the change in gravitational potential energy, and when the object is moving, so it's not above the ground, for example, it has kinetic energy, and we just have to substitute those particular values in. Now, one key thing to say, and I know a lot of specifications pick up on this, is that energy cannot be created or destroyed. It can only be transformed or changed into another form. So, for example, electrical energy into a particular device. Let's say you simply, the most useful form of energy that you'd want is to be able to see something on a screen on that device. So you'd want it to be transformed into light energy. But you're going to get sound. You're going to get some of that energy being transformed into heat, which may be wasteful. But the key thing is that you're not destroying or creating it. You're simply transforming into other forms. Now, those other forms may or may not be useful. And one of the reasons why I'm just mentioning this is because particular specs refer to something called regenerative braking. Now, some hybrid cars actually make clever use of this regenerative braking, and it's where the brakes are designed to convert some of the kinetic energy, so some of that moving energy, back into energy that can be stored in the car's batteries. Now, obviously, it's much more efficient, not just in terms of the environment, but in terms of the costs of running the car. So that's just a little something extra there, because I know some specs pick up on this idea of regenerative braking, and it's simply turning some of that kinetic energy back into energy stored in the car's batteries. So there's a big interplay between these two. So you may notice as well in an experiment that you may do, that if you calculate a value for GPE, the value that you get for KE may be much, much lower. And it's not that that energy is being destroyed, it's just that whilst the object's then in motion, some of the energy has actually been transformed into other more wasteful forms. So there's a little video there just on how to calculate GPE and KE and the factors that are important to be able to calculate both, and we've got a definition for the two there. Okay, hope all that helps.